Hello again YouTube. Today I've got another window actuator to show you. This is one that's it's actually faulty, but it's been taken from a job. This has been replaced. But this one's, although it's faulty, it still does run to a degree. Like once I start to run it, you'll hear that it's very noisy, and it shouldn't be. It's much noisier than it would normally be when it was working properly. You can see here I've obscured some of the details from the actuator. I don't have permission from the manufacturer to show you the detail on this, so I've obscured it. The reason I've done that is because I work in this industry. I work in window controls, and you might think, well, once something's bought, it doesn't belong to the manufacturer, but it's a little more complex than that. Because I work in the industry and I have an affiliation with one of the manufacturers, I tend to obscure or anonymise the actuators when I get them and take them apart. This one in particular, this is quite a rare actuator to see on the bench, and I'm going to have to take it outside and show you on the decking because this is an absolute monster. This is let me just see if I've got a tape measure here. The overall length is 870mm, so it's quite a big beast. It's over 50mm, it's what, 53mm wide, and the depth of it is 80mm. Oh, it's gone off shot, it's that big. So it's 80mm deep. The chain, you can see the chain here, this is an absolute beast. Look, it's the size of my thumb. So across it's about 25mm, and the cross section about 25mm, so it's 25mm square. This chain gets referred to as elephant chain because of the size of it. This type of actuator gets used commonly on roof lights. So this is a double glazed window that's on the inside, or sorry, on the roof of a building. So if you're ever in a school, a health centre, an office block, and you look up and you see there's a horizontal window, a flat window on the roof, that's a roof light, and if it opens, then it'll be an opening light, and that something like this will be installed to it. This particular actuator, this is, in my opinion, this is probably the best actuator there is on the market at the moment. It's certainly the most intelligent and configurable. It has a number of features, and I'll try and show you some of the features if I can. I do have a diagnostic tool here that will let me change some of the parameters, and it will let you show you at different speeds. But first I'm going to take it outside and put it on the decking, and I'll let you see the actual size of this because it is an absolute beast. I'm going to open one of these up and show you inside it. I've got a couple of these, they've both come off the same job. The reason they're on the bench, they're quite old now actually, these are about 6 or 7 years old, but the reason these are on the bench and the reason I have them is because they were water damaged. The way they were installed, the people who installed them left an issue on the roof light, and it let water get in down inside of here, and that's why one of them's not working at all. It's just seized up. This one is working, but it's quite noisy. So let's take it outside and have a look at it on the decking. As you can probably see, it's another beautiful day in the west of Scotland. This is the actuator on the decking, and the chain's fully extended, so that's 1 metre long, that chain. Let's see if I can drive it in. You can probably see from the rust on the chain that this has suffered some water damage, and that's what's wrong with this actuator. Once they're water damaged like that, they can't be used for life safety systems, if you can't guarantee that they're going to work when they're needed. This is also missing its end caps. Normally you would have end caps there for the brackets to mount onto. Okay, now that we've had a look at it, I'm going to show you some of the features. It is a window actuator, so nothing's going to be that exciting, nothing's going to flash or go bang. But if you're a window controls engineer like me, some of the features are actually quite exciting in their own. When you're able to control a window quite precisely, especially a big window like this would be able to control, then being able to do something like that gets exciting, because it means it can change what you offer your customer. So I'm going to show you the basic operation of this. So let me just power up the diagnostic tool here. So at the moment, although the chain's out a little bit, this thinks the window's closed, and the reason for that is the chain can go all the way back in, but it knows this to be its closed position, and that's programmed into the processor in here. You can change the closed position, you can program that quite easily. So if we change one of these over, it's not a big deal to tell it where its closed position is. Now that's important, because the closed position won't always be all the way down here. Sometimes it might be up here. If this is installed quite far away from the actual frame of the window, you want to be able to adjust that. Some of the more basic actuators on the market let you adjust that using a screw or just a little extension rod. This one's actually done via the programming, so you don't have to worry about getting all the way back up to the roof if something needs reprogrammed. You can do it through the cable. So let's see if we can try running this and let you see how it operates. As you can see, as the chain makes its way out, it is quite a beefy chain. Let's flip it over. You can see it. It has these cogs in it, much like a cycle chain, and inside the actuator it has a cog, just like a bike cog, that drives the chain in and out. This chain is particularly long. This is 1 metre in length. That's about the longest chain you get. Any longer than that, if you had to drive a window open further than that, you would have to use a different method. But 1 metre's a long distance for a chain. So I'll just stop that there. So you heard that coming out. It is quite noisy. It's noisier than it should be, but it came out at 1 speed, and that's how most actuators work. They've got a fixed speed, but not this one. I'm going to drive it back in. I'm going to vary the speed as it comes back in. The programming of the actuator, you can tell it to have a normal speed. So you tell it what speed it is when you apply voltage to it. Now this is quite an intelligent actuator. It's got 3 cores on the cable. Let's just see if I can show you that. So it's got a brown core, a white core, and a green core. And the green core is a data core. It communicates with the actuator, a bit like the CAN bus on your car. So you've got 0 volts, and in this case it's 24 volts, and then you've got a communication core. And that's quite important here, because without that, all you could do is apply voltage to this and it would either drive in or drive out. Now you can do that with this. You can just put it into simple 2-wire mode and it'll just drive in and out at whatever speed you tell it is its normal speed. But if you use the communication core and you use it with a panel that's compatible, you can tell it to drive at different speeds in different situations. And let me explain why that's important. Say this was installed in a school and it was in a dining hall or an assembly hall. So you can use it for multiple functions. So this one, you can use it for comfort ventilation. So if it gets too hot or if the CO2 level gets too high, you can drive the window open with this. You can also use it for safety. So if there's a fire in the building, you can use this to drive the roof light open to vent smoke out. Now, those 2 things you don't want to happen the same speed. If you run it fast all the time, you shorten the life of the motor and they're very noisy. If you run it slow all the time, you won't open it quick enough when you need it to open for life safety. And also there might be other reasons why you want to open it. So for example, let's say it is in an assembly hall and there's an exam on and you want to open the roof lights, and say there's 20 or 40 roof lights. The last thing you want is the roof lights to be making a big chuntering noise and motors running and disturbing the kids who are sitting in exam. You want them to open really quietly. Or you might have a dining hall full of kids and it's very noisy and you want to open them fairly quickly and you want someone to press a button and it'll open at a medium speed. So with this type of actuator, all those things are possible and more. You can have up to 4 different predefined speeds on this. So you can have a speed where it's safety, you can have a speed where someone wants to press a button and open it, you can have a speed where the building management system or sensors detect the air quality and open them nice and quietly. And there are, as I say, there are other options. So let me just see if I can demonstrate multiple speeds on this. Okay, so that was it right up to its top speed, which is this. And for a window, that's quite fast. Now, you probably also noticed that when it got back in, it was almost closed, it slowed right down. And that's a safety feature. It's for 2 reasons. In case that someone has their fingers trapped in there, it goes into slow mode so that it won't trap your fingers so violently. And also it senses the force here. So if something was trapped in it, it would sense that and it would actually open the window again to let your hand out. So it goes into second speed, slow speed to do that. Also at the slowest point, you want the window to close and then compress the rubber seals so that it's airtight. So it slows down to make sure that that's done in a controlled manner. It also does the same on the way out. Before it gets to the very end of its stroke, it slows down before it opens the window fully. Again, it's to make sure that it comes to a controlled stop and you're not putting undue pressure on the window or the chain when it comes to that stop. Apart from the speed, apart from the multiple speeds, there are a number of other things we can do with these. So for example, if you had a very big window or a very big door that you wanted to actuate, I could tell this that it's part of a team. So, and then I can tell it how many other actuators are in that team. And what happens then is if one of them stops for some reason, let's say you have them open on a window and there's scaffold outside and one of them catches the scaffold and stops, all the other ones will stop as well. And that's important so that it doesn't damage the door or the window, because if they kept going it would destroy the window or it would smash the glass. If you can see on the rating label here, it's a 24 volt DC actuator. It runs at 120 watts maximum, so that's quite a lot. 24 volts DC, 120 watts is 5 amps, that's a lot of power, and it'll output 1000 newtons of force. So 1000 newtons, if you imagine if you had 4 of these on a window, that's a lot of power. That's a lot of power to apply. These are maximum values, and again on here you've got the duration, so the duty cycle, 20%. Basically that means you can run it 2 minutes in every 10 minutes, which is its expected duty cycle. If you run it more often than that, you would risk overheating the motor and shortening its life. But these aren't the kind of things that you run constantly. You open the windows and you leave them open until it's cool again, and then you close them. You close them in a controlled manner. This will open pretty quickly. At its full speed it'll open in about 60 seconds ish. So you wouldn't be running it for 2 minutes every 10 minutes. So it's designed just to open the windows and close the windows in a controlled way, not to be played about with, if you like. So there are a couple of other features in it. I won't go through each of them. The programming tool that I have here. I'll show you it briefly. Again, the manufacturer's name has been obscured. This programming tool lets me change lots of parameters in here. So I can change the force, I can change the speed, I can change the chain length. So for example, at the moment, this chain has a maximum length of 1000 millimeters. If I wanted this to stop at a different length, let's say 768.5 millimeters, I can do that. I can program it to stop at exactly that. The dividing position, so I can decide that the point at which it slows down before it closes, I can change those. And you've got dividing position for the way in and the way out. I can change the team size, and I can make this part of a team of up to 4 actuators. And then there are lots more parameters that I can change here, but those are the main ones. Those are the things that we would commonly change to make this actuator fit for a job. Okay, now that we've had a look at it and we've had a look at some of the things it can do, I'm going to see if we can get one of these open. Now, opening these is a one-way process. The way these are constructed is there's an outer aluminium case or an extrusion. Inside there's another aluminium case, but it's not as pretty, and that's why it's encased in this. Also, the chain is exposed in here, so this contains the chain. So the main body is assembled with the motor, the circuit board, and the main chain inside. Then the chain's brought up through, and this first rivet is put in with this end piece on. Once that's in, it can't be brought back out again without destroying the chain. So I've got 2 of these, the other one doesn't work at all. So I'm going to take that other one and I'm going to cut the chain off it with a grinder and see if we can get the body out and have a look at what's inside here. Well, that was quite an ask. I've managed to get the end of the chain off, but it's taken quite a while, and as you can see, it's done a lot of damage. My bench is a mess. I was able to grind off part of the chain, but then I was able to grind off the end of the rivet, but then after that I was forced to basically go at it with a hammer and chisel, because the rest of it wouldn't come through. So now what I'm going to do is try and drive the chain back inside the case and see if it will come past the outer casing, and then that'll let me slide the rest of the motor out. I've got the innards out. The outside is basically just one big aluminium extrusion. It's just a big channel. There's nothing inside it. It's just a metal tube. Inside's in 2 sections. So we've got this section here, which is the actual motor itself, and you can see there's a couple of cogs here protruding through. At the back here I can see the body of a motor, and then this front section is where the chain is encased. I'll just show you the other end of it. You can see the chain poking out. Now this front section is about 500 or 600 mil long, so it's quite a beast of a thing. Again, it's just an aluminium extrusion, and all it's doing is housing that chain. It causes the chain to come up to the end, fold over on itself and go back, and that's how it folds the chain flat inside the end of that casing. So I'm going to take this extrusion off, and then I'll drive the chain out, because we don't need the chain anymore. It'll let us look at this section, which is the motor, where the interesting parts are. And inside there we've got the actual chain itself. As you can see, it's folded back on itself up the end here. All we've got is a big loop of chain. So the chain I've driven back in, and let's see if I can drive it out completely. Okay. So hopefully this is going to let the chain come free. Yep, there we go. And that's the end of the chain out. Straight away I can see the main board is potted in resin. That's obviously to try two things. It's to keep it watertight, but it also stops you seeing what's on here, which is a shame because there's actually quite a lot in this. Now I'm going to lift this chain away. Let's say the chain is the pin that holds the chain on, and itself's a bit of a monster. The chain is huge. Right, and here's what we're left with. This is the actual drive itself. So we've got the motor here, and that is a beast of a motor. Look at the size of that thing. Remember, this is only 24 volt, so that's an actual, that's about, I guess that's probably the chunkiest 24 volt motor I've ever seen. This here, this bit's a chain guide. It just drives the chain up and round, and you can see where the chain is ridden on it, so the inside of the links ride on there. I don't think there's any more screws. No. Let's just see if I can lever this off. This isn't going back together, so I'm not worried about damaging anything here. But you can see from that piece of machining, that's an absolute beast of a chain guide. When the chain comes out, when it's driving in or out, you can feel the chain moving a bit, and it's because these two nubs here, the links in the chain, or the pins that go through the chain, run over these. Now I've often seen that happen and wondered what causes it, and it's this. So that must be by design. It does that. There is a little bit of play on the pin that holds it onto the window to let it move, to adapt to that. So I guess that's to stop any binding or anything getting caught up. This is the main drive cog. So this is the one that drives the chain in and out, and as you can see, it's like a bicycle gear on steroids. Look at the size of that thing. It looks as if it's made from one piece. Could be wrong, but no, it looks like it's made from one piece. Yeah. So as far as I can tell, yeah, there's no seams all the way through it. That's quite a piece of engineering on its own. Can't tell what kind of metal it is. I'm not that kind of engineer, so I can't tell if it's sintered, but it looks like it's been machined, because it doesn't have that powdery appearance that a lot of like this metal, like this aluminium case has. Sometimes you open up an actuator, especially the smaller, cheaper ones, and you can tell the gears have been poured or moulded. This doesn't look like that. This looks like it's been manufactured from a block of steel. And we've got the drivetrain works. So the actuator drives. You've got this Archimedes screw. It's a worm drive, some people call it, and then you've got a set of reduction gears. This motor will turn at quite a significant speed, but straight away it goes from an Archimedes screw onto a toothed gear, and then there's a further reduction here, and then as it goes across the gears, each time it goes across the gear, wow, the weight in that, I lifted that off thinking it was magnetic, but it's just the weight of the thing. Again, that looks like one piece. Yeah, there's no seam on that, there's no bearings. These are these look like they've just got a very snug fit. There's no play in that whatsoever. These go on, they feel very, very smooth. So it's obviously just this has its own bushing. It's just designed to sit right on that pin. Again, another drive gear, again one piece. This one just takes this gear here to the final gear. This is the one that comes off the motor, and I'm expecting that to be plastic. And pretty sure it is. I'll just grab a rag here. Yeah, That's a plastic gear. So in any kind of actuator that I've ever looked at, no matter what kind, you've always got one plastic gear. And I'm assuming, yeah, that's plastic. It's either in fact this piece looks metal. So this is a two-piece. This is this bigger gear is pressed into the plastic part. I don't think I can get it out, it's probably toothed in there. But in any kind of actuator motor like this, you've always got a plastic cog, and because you have to create a failure point somewhere in case there's some sort of catastrophic event, and somewhere has to give. So this would fail if this all locked up and this kept going. If all the safeties failed, then this is a final safety, and this will chew and destroy itself, rather than destroying the window or, you know, causing some physical damage to a person. So that's pretty much it. And then you've got this beast of a motor. I've never seen a 24-volt motor as big as this. Let's wipe my hands. Get some of that grease off. See if we can find even a manufacturer. Like I said before, when we were looking at the rating plate on this pulls 5 amps, and that 5 amps is coming through this motor. Sure, there'll be a little bit of current in the PCB down here. It's a shame we can't see that PCB, but never mind. That 5 amps will be coming through here, and I can't get that. It won't slide. Often these outer jackets will slide, but this one isn't for budging. Because sometimes you can see the manufacturer's stamp underneath. Oh, hold on, I've got something here. It's an RS 755 VC, made in China, and I can't see the rest because it's under a sticker. It's a 4540. That's all there is. So RS, I don't know if that's RS components, and I'm not entirely sure. I know RS components do have manufacturing. I'm not sure if they actually manufacture or they just rebadge stuff. And I don't know if I actually don't know if RS components exist outside the UK. It's something I've never considered. But let's see if I can drive this motor while it's sitting like that. Yep. So what I can tell you is there's a bearing on the end of this shaft. Now that's quite unusual for an actuator. Now the reason that would be there is because of the size of the shaft, the breadth of it, but also so the length, rather, because of the length, how far away it is from the motor. So it will need some control here to stop it damaging the teeth on that gear. But also because of the amount of force that this is transferring. Because, like I say, there's 120 watts being consumed here. That converts to, like I said before, 1000 newtons. So there's a lot of force in that 1000 newtons. There's not 1000 newtons here. There's more speed and less torque here, but by the time you get through all these gears, it converts to 1000 newtons. That gives it a really nice control. So this isn't going to be bobbing about, and that's very, very smooth. That's really nice. On the back end, initially I thought this had a bearing on it, but it's not. It's actually fixed. This is fixed to the impeller. This is a ferrite or a magnetic core, and I can see poking up through the potting solution here a Hall effect sensor, and that's how, when this is in use, the actuator drives the chain, and the actuator needs to know where it is, so where the chain is at the start, at the end, how far out it is, so that it can start and stop in the right places and change speed in the right places. And this is how it does it. So for every rotation or quarter rotation of this here, that'll equate to a length on the chain, and that's pre-programmed into the chain for the chain type and the actuator type. And unfortunately, because of the potting solution, that's all there is to see. Down here, I can see 4 squares here. Now these are possibly MOSFETs for driving, for switching on and off the current. There has to be a chip somewhere, there has to be a microcontroller, because this, as I said earlier, this green core is a communication core, so it has to be communicating with the main control board to tell it what to do, and all of that has to be decoded on here somewhere. I think I can see the top of a component here. It's possibly an inductor, possibly a capacitor, but looks more like an inductor. And the only other thing I can see is that ferrite ring, that's a suppression ring, and there's unfortunately nothing else to see. But even the weight and what's left there is pretty substantial. Now, these are not cheap, these motors. So these are pretty specialist. They're for double and triple glazed roof lights. The size of the size of the window that this will open is not far off the size of your front door, and they'll do even bigger if you put multiple actuators on the same window. So it's not often you get a chance to see these. This is actually, I think, the first. Yeah, this is the first one of these I've had on the bench, and in the 5 or so years I've been doing this. They're very reliable, they're very well engineered. As you can see, all the components are extremely well engineered. This one, as I said initially, you could see there was water damage on the chain, and for that reason that's why it got taken out of service. And that's also why it was running a bit noisier than it would normally do. They're very good quality actuators, very versatile. They can be programmed to do a lot of things. Like I say, they've got multiple speeds, they've got multiple safety features, but it's nice to be able to see one. It's nice to be able to actually get your hands on components of this size and this quality. That was good to see. So I hope you enjoyed this video. I hope you found it interesting. If you don't work in window controls, then maybe you didn't, I don't know, but if you didn't, give it a thumbs down. It still gives me a bit of feedback as to what people like and dislike in my videos. So if you did like it, please give me a thumbs up, consider subscribing, and I'll see you in the next video.